All right, so I've had a lot of questions about uncertainty in these Stoich labs, and so I'm going to walk through some of the different kinds of uncertainty calculations that we do. This is specific to the iron oxide lab, um, but the calculations would apply to everything that we're doing. So first of all, absolute uncertainty, that is simply what our scale tells us is our wiggle room. For the scales at home, they are plus or minus 0.01 grams. So that's our absolute uncertainty. When we average, we're going to average the uncertainties as well. So let's say that my initial iron masses for my three trials were going to be 0.30, 0.31, and 0.29. So these are my three iron masses to average. I'm going to add them up, divide by 3. I made the math easy. It's going to come out to an average of 0.30 grams. To find my uncertainties, I'm going to average those as well. So 0.01 times 3 divided by 3 is still plus or minus 0.01. So this would be my average iron mass, my average uncertainty for the iron. Iron oxide is going to be the same thing. Let's say that we had 0.49, 0.51, and 0.50. Add that up, divide by 3. That's going to give me an average of 0.50. My scale is still a plus or minus 0.01 for each of those. Add up, divide by 3. My uncertainty is going to be plus or minus 0.01. So that's the easy part. Relative uncertainties. What we're going to do now is figure out how much this matters in relationship to the quantity that we have. So we're going to take the absolute uncertainty plus or minus 0.01, and we're going to divide it by the mass. So for iron, it's going to be 0.30. Turn that into a percent by multiplying by 100. My calculator says 0.01 divided by 0.30 times 100 is going to be 3.3%. And then over here, 0.01 divided by 0.50 times 100, 0.01 divided by 0.50. Oopsie. I missed a button on my calculator. Is going to be 0.02 times 100 is a 2% uncertainty. So this just tells us that we're off by about 2%. Not that much. If instead of 0.50, let's say that we had 0.05 grams of iron oxide, if our absolute uncertainty was 0.01, still this is now going to be a 20% wiggle room in my measurements. This is pretty substantial. 2% is not that big a deal. This is why we calculate relative uncertainty. So things get trickier when we start subtracting. So my average iron oxide was 0.50. My average iron was 0.30, so my average oxygen is 0.20 by subtractions. In terms of uncertainty, things get really weird when we subtract. So remember that this was plus or minus 0.01. The iron was also plus or minus 0.01. We did that on the previous slide. To find the uncertainty when we subtract, what we're going to do is add the absolute uncertainties. So we're saying that if I've got this much wiggle room in iron oxide and this much wiggle room in iron, when I subtract, I'm going to have all of that wiggle room included. So I'm going to have a plus or minus 0.02. So when we subtract or when we add or subtract data, we're going to add the absolute uncertainties to find the uncertainty of my that difference or that sum. So I have 0.20 grams of oxygen plus or minus 0.02 grams. It's a bigger uncertainty because I have the uncertainty of this guy and the uncertainty of that guy adding up. So now I'm going to find my relative uncertainty. We're going to take this absolute uncertainty and divide it by the mass times 100 to make it a percent. 0.02 divided by 0.2 is going to give us 10%. So you can see the more calculations I do, the more impact our uncertainty has. Because this isn't a direct measurement, but instead it's the combinations of lots of measurements that each have a lot of wiggle room. So my relative uncertainty is 10% here. My absolute uncertainty for the oxygen, because of the subtraction, is 0.02, plus or minus 0.02. So now let's go ahead and figure out mass percentage. So I had 0.30 grams of iron out of 0.50 grams of iron oxide. And then we had 0.20 grams of oxygen out of 0.50 grams of iron oxide. So we can divide, multiply by 100. This is going to give me 60% iron and 40% oxygen. So that's an easy piece. Uncertainties. This is where things get kind of crazy. So when we divide, we're going to find the square root of the sum of the squares of the relative uncertainties for each mass. So iron and oxygen, I'm going to go back a couple slides. Our iron relative uncertainty was 3.3%, and our oxygen is 10%. So iron, I'm going to turn it back into a decimal point, 033.10. So these are my relative uncertainties that I found earlier in the lab. So now what we're going to do to find the uncertainty of this whole, oh, I forgot my iron oxide. Let's go back to this one too. We also need this one, 2% for iron oxide. Sorry. Good. Iron oxide is 0.02. So when I did the division, iron divided by iron oxide, to find my uncertainty, we're going to do 0.033 squared, because that was the relative uncertainty of my iron. I'm going to add the relative uncertainty of my iron oxide, which was 0.02 squared. And then we're going to take the square root of that whole thing. 0.033 squared plus 0.02 squared, square root that, square root, sorry, I missed some buttons on my calculator, is going to give me a 0.0385, 8 lots of digits. I'm going to multiply by 100 and round to just one decimal place. So 3.9% is my uncertainty for my percent composition iron. For oxygen, we're going to do the same thing. We're going to take our 0.10 relative uncertainty for our oxygen. We're going to square it. I'm going to add to that my relative uncertainty of the iron oxide, square that, square root. And again, we square and square root because we're dividing. So when we add and subtract, we simply add the uncertainties. When we are dividing, we find the square root of the sum of the squares of all the relative uncertainties. So on my calculator, 0.10 squared plus 0.02 squared, find the square root of that, and it's a much bigger number, 0.10198, lots of digits, times 100, round to one decimal place, it's going to be a 10.2% uncertainty. So because iron and iron oxide, I measured those directly on my scale, that uncertainty is less. Because this oxygen mass came from some calculations, the uncertainty is larger, and so that percent composition uncertainty will also be larger. Hopefully, that's a help. Let me know if you still have questions.